Tyler is a sales engineer manager at Fortinet. He has over 15 years experience with it in security leadership before transitioning over to technical sales. So he used to be one of us, a techie guy, then he went into sales, but we still got something to hear there. Tyler is passionate about tech, cloud security, and helping customers. He's a father of 4, an avid hiker, football coach, and traveler. Tyler. Yeah, there we are. Thank you. Here you go. Thank you. Can we have a round of applause, please? Thank you.
You guys hear me okay? Sometimes my beard gets in the way. So first off, I have to say, and I don't know if you remember the slide that was just on here, kudos to the AI team for actually giving me hair. I haven't had hair in about 25 years, so that was awesome. All right, let's get to beginning. So as mentioned, my name is Tyler Germer. I work for Fortinet. I was actually part of the Lacework acquisition back in August. Lacework was a CNAPP platform that helped protect the cloud space. So I'm going to talk a little bit about cloud security today and give you a little agenda here. Talk a little bit about cloud security, paint a picture for you of based off some market research that we did in the past. There's actually a report that you can link to called the Fortinet 2024 Cloud Security Report. It goes through some market trends around cloud. So I'm going to talk a little bit about the cloud space today, talk about the problems with cloud security, talk about the challenges that people are having, how they're trying to solve them, the mistakes they're making, and the actual desired approach to better protect your cloud and better keep your sanity as you move into the cloud space. So as the great Bob Ross, or in this case Owen Wilson, would say, let's paint a picture. So first metric coming from that report. What does cloud look like? How are people actually architecting in the cloud? So when cloud first became a thing, there was apprehension. Obviously, it was new. It wasn't tested. People didn't know how to architect in it. It was a new space. Then over time, it became a challenge of let's get everything into the cloud as quickly as possible, as fast as possible, as efficiently as possible, and as cheap as possible. And then after a while of people migrating into the cloud, they start to have that thought of, well, wait, what if, heaven forbid, one of the clouds goes down? So then the idea of a multi-cloud strategy became more and more popular. Over time, and as companies started to hit some apprehensions or some resistance or some problems with migrating to the cloud, this idea of hybrid cloud became popular. Hybrid cloud being keep some things on-prem, keep some things in the multi-cloud environment, and sort of keep the sanity. Some of those things come from architectural challenges of migrating to the cloud. Some of it is mandates to keep certain data on-prem or in data centers. So multiple different reasons. Some of it's financial. But as we polled the market, common theme, a little bit on-prem, a little bit of multi-cloud. And then in addition, what keeps people from going all in on cloud? Besides what I've already mentioned, security and compliance. So a big part of what my talk is today is the concern around cloud is different. Cloud is a lot more complex. There's a lot of moving pieces, tons of services, regardless of cloud provider. A lot of complexity, a lot of data, a lot of logs. So how do we secure that? How do we meet compliance mandates like SOC 2, ISO, PCI, HIPAA? Technical challenges. How do we take something that is designed to be a vertical, monolithic beast of an application in our own data centers and move that into a cost-effective method inside the cloud? Resource constraints. Constant issue in the market for the last several years. There's not enough people to do the work, not enough people that understand cloud and understand security and can help us not show up on the front page of the news. And then organizational, operational factors. This again goes back into things like knowledge levels, experience with the cloud, how do we face those challenges as we migrate. As we dug a little bit further into, and again, a lot of these metrics that I'm referencing are in that Fortinet Cloud Security Report. As we dug in a little bit more, it became very apparent that that lack of skilled people to do this job, to understand what it took, to understand the complexity of cloud, was really, really apparent in the about 1,000 people that we talked to. And the other part of it was cloud security people comparative to on-prem. There are some areas where they cross paths as far as the knowledge level and the technical skills that they need, but there's a lot of unique areas as well. So obviously the cloud and application security, identity and access management, not giving everyone entire rights to the kingdom, making sure they have what they need to do their job, but not so much that if you were to get breached, it would cause a massive problem and that person would have access to everything inside of your environment. Things like risk and compliance we've already talked about. Threat intelligence, getting additional information to understand known bad actors, known bad threats, ideas for reducing risk in your environment, and a couple of other things here. So up to this point, we've talked about metrics. What is the market doing? How are they doing it? What does cloud architecture look like? I wanted to take just a couple of seconds to talk to the complexity of on-prem versus the complexity of cloud. So this is a fairly basic dumbed-down diagram just showing what an average data center configuration would look like for on-prem. So you've got a couple of data centers, a primary and a secondary, so you've got a failover. You've got some WAN links connecting to branch offices, corporate offices, things of that nature, and the connectivity between them. A couple things to point of note. When you're on-prem, you've got very well-defined edges to your environment. You know where things come in, you know where things go out, you can protect it, and then inside the walls of each of these spaces, you know you have tried and true software, tenured knowledge of people that know how to protect these things, and applications and software platforms that are designed to keep them safe, protected, let you know when things go awry. Now let's look at this same diagram, but from a cloud perspective. Just a couple more pieces to it. You look up and it's a little bit hard to see, but up on the top of each side, you still have that on-prem piece. You've got corporate offices, you've got branch offices, you have areas where people still need to connect in. It could also include remote access, things of that nature. But then there is a slew of services and features and functionality that you have to deal with and manage. A lot of extra data sources, logging. So it's not as easy as to just lift and shift something from on-prem to cloud, have the same security, have the same configurations, and understand it. And this is just the architecture and the infrastructure around cloud. If you look at the complexity of an actual application running inside of cloud, this is an example of AWS from a logging perspective. IPs going in, particular services, particular regions, using particular IAM roles, running particular services, and then potentially connecting out on the other side to something outside those four walls. So a lot of complexity. And all of these different hops, all these different icons, everything is creating a log, generating data. So when you combine that with the fact that there's not enough skilled staff to look through all this data, the data is exponentially larger than it used to be. Time is cloud security's #1 adversary. And I want to cover these three metrics on here because I think they're important to sort of drive home what I'm trying to get to. Vulnerability management. You have a vulnerable package on a server or an application or a set of boxes. Inside of the cloud, 65 days average mean time to resolution to just solve a vulnerable package on one host. When you think about the idea of microservices, Docker containers, things of that nature, that one host may have several different things that it relies on to feed information to it or send data out. If you patch a vulnerable package and it does not function with previous versions of other packages, you break that process. You break production, you break development. So it's not as easy as to just quickly change something out. So that's why the 65 days. So time is the #1 adversary. You need something that can help provide opinion, tell you what you should be working on, what you should prioritize. This number, extremely scary. 241 days average time to detect that someone is even in your environment and then solve the problem. Ideally, you have knowledgeable people that you've hired that are going to understand what to do when a detection is found. But see, previous graph, how do you find the needle in the haystack? Bad actors are going through a lot of the same things that we're doing. They're utilizing AI. They're understanding the software platforms that are used to detect lateral movement and problems inside of their environment. So they are getting into your environment and they move slow. They get access. 85% or higher of breaches use known good credentials. They're not brute force attack. They're not attacking your front door. They're using credentials that are given to them by phishing attacks, spear phishing, whale phishing. They're getting access, social engineering. They're getting access to the environment. So nobody can see what they're doing. And they get in your environment and they sit. And then they wait a week or two, and then they move over to this host, and they do more stuff. And so on and so forth, so that when they decide to push the button, 5 hours to get all the data that they need from you and walk away. Whether that's ransomware, malware, whatever the case may be, 240 days to sit there, 5 hours. And a lot of this, again, is from the complexity of cloud. There's so much data. There's so many logs. How do you make sense of all of it when you don't have enough people, they don't have the right skills, and you may not have the right tools? Now, what are the common methods that folks in the cloud security space are trying to attack this problem? First side, risk-based approach. So I like to give the analogy of the house. Think you have a house and you want to keep people from getting in. So the first thing you do is you lock the doors. Turn on your motion sensors, close your garage, maybe you turn on the security cameras, do all the low-hanging fruit, the things that keep you from having someone break into your house. In the case of cloud, misconfigurations. Make sure you're configuring your stuff right in the first place. Solving vulnerabilities takes 65 days. It can be time-consuming. Protecting secrets. Looking at what your users are doing. Do they have too much access? Do they not have enough? What are they doing? Is what they're doing today what they were doing yesterday? Do I have compromised credentials? And entitlements. So the risk-based approach is definitely a valid part of cloud security. You want to protect the things that you can control first. I can control user access. I can control misconfigurations. I can control vulnerabilities. So do the things that you can control first. But the problem is, again, back to the analogy of the house, what if someone gets inside your house? This means nothing. They're in your four walls. They already have access, so the door is open. So that leads to the next approach, which is threats. So risk mitigation, proactive side. Do what we can beforehand, before they get in, to reduce the chance that they're going to get there. If they do get in, how quickly can I detect that they're in there? Previous metric, 241 days. Takes a long time to find a needle in a haystack that just grew exponentially because I migrated to cloud. So we look at events. Maybe you have a SIM, maybe you have a SOAR, maybe you have some sort of a logging mechanism. We're looking at processes, API calls, connections, logins. What are they doing? How long have they been there? Do I expect the actions that they're taking? So it is that reactive, let's look at the data, let's deal with what we're seeing, let's see if we can find the bad actors. But again, previous analogy, they go in and they wait. They're not doing 1,000 things. They take days, weeks, months, a little bit here, a little bit here, a little bit here. So when they press that execute button, they don't have to be there long to get what they need. So again, threat detection, absolutely needed in the cloud security space, but it's not enough. And the next part becomes, I'm not sure how many of you have actually looked in the sort of the cloud security space and the number of vendors and options that are out there, but there are thousands of siloed solutions that do one thing, maybe two. So maybe they just tell you vulnerabilities and that's it. Cool, you want to know the knowledge. They tell you what users do, or they look at API calls and that's it. The challenge is that data doesn't talk together. You can't correlate. You can't use behavior analysis. You can't use AI or machine learning. Take advantage of some of the new tech that's out there to say, but what happens if I put it all together? What does that look like? This is the desired approach. Take one platform that does all of it. So you have your risk-based approach where you're trying to do as much as you can to keep them from getting in. On the opposite side of it, make sure that they do get in, you know, as quickly as possible. And somewhere in here, don't rely on users that you may not have enough of to analyze all that data, because it is too much for one human or a team of humans to dissect all day long. This is where you use AI, behavior analysis, machine learning, analyze that data so that you can have interesting correlations, such as a reactive correlation to say, hey, I can see that this particular host is internet exposed, so it is accessible from the outside world. I can see that it has this misconfiguration. I can see that on top of that, it has this vulnerability. And based off the IAM roles that have access to it, we believe that this host has a huge chance of being breached. So we're going to prioritize that for you. Or vice versa, on the threat side, you have been breached. We have examples of ABCD that show you have an active breach in your environment. To help you solve that breach, we see back here in things like infrastructure as code or misconfigurations or vulnerabilities, this is why it happened. Here's how to solve it quickly so that you're not taking 241 days to stop the person or the bad actor from continuing to bounce around your environment until they get that data that they want, whether it's PII, PHI, IP, whatever the case may be. And it's not just us that's saying that. Again, from the market trends perspective, having a single platform where you can see all of your policies, your configurations, your vulnerabilities, threat detection, all that in one place, that is what the market wants to see. And you'll notice in the cloud security space now, we are consolidating a lot of vendors, similar to what happened with Lacework becoming a part of the Fortinet and their drive towards more cloud visibility, cloud strategy, cloud security, along with their other products. That's what's happening in the market now, is people don't want 100 different siloed solutions where they have to piecemeal things together in the midst of a breach. They want to have that correlation. And with that, that is my talk.
How are you?
Good.
Good, thanks. Just looking up the questions here. I just got one question for you from the group. What class of, this is a bit personal, what class of security issues keep you up at night personally?
Honestly, from that metric that we saw, the fact that bad actors exist in our environment for 240 days before we find them, that keeps me up at night, because we had 240 days to find what was happening, and because of the mass amounts of data from cloud, we just don't see it. Not enough people, too much data, too much human intervention required. So that's what keeps me up at night.
Great. Thank you, Laura.